My name is Justin Hendrix. I'm Executive Director of a thing called NYC Media Lab, which is a consortium of universities in New York City, including NYU and Columbia.
The title for this is Math the Primary Ingredient in Tomorrow's Magic? And I'm hoping we'll have a conversation today about the role that data and data science can play in innovation, in product development, and creativity. And I hope also that you will participate, so we'll get to a point in the conversation where I'll ask for your questions, so please start to formulate those now. I've asked our panelists not to be too kind to one another in the course of this conversation, so I hope they'll respect that and go at each other a little bit in a playful way on this Friday afternoon. I'm going to introduce them very briefly, and we'll get straight into the conversation. And so, to my far right, Chris Wiggins, an applied mathematician with a PhD in theoretical physics, working on computational biology at Columbia University. You can't say that before noon. He's also, right now, known these days as the chief data scientist for the New York Times, which is a regional news organization some of you probably heard of. And he is also leading up Hack NY. And he's doing all these things right now, so the fact that he's taken some time to be with us, we appreciate. To his left, Alison Schrager, an economist and writer currently writing for Reuters and Quartz, doctorate in economics from Columbia, where she specialized in macroeconomics and public finance. Recently wrote a column in Reuters that asked in the headline, should we believe more in big data or in magic? So she's in just the right session. And in fact, I think she spent about a year socializing with magicians in order to write that column. So we'll get on to that too. Then to her left, Matt Turk, Managing Director of Firstmark Capital, where he invests in a broad range of enterprise and consumer startups with a predilection for big data and driven products and other software ventures. Prior to that, at Bloomberg Ventures. How many of you have attended Matt's Data-Driven NYC events? Okay, a few there. If you're in this audience, you're likely, you should be part of that meetup.
And yes, I'm 4'11".
He is in the short seat. We apologize for that. And then to his left, Gilad Latan, who is Chief Data Scientist at BetaWorks, a technology company that operates as a studio, building new products, growing companies, and seed investing. Previously, Gilad ran the data team at SocialFlow and built visualizations at Microsoft's Fuse Labs. So we have an excellent panel. And I'm going to first put a silly question to them, and I'm going to ask data science. Magic? Not magic. Chris?
There's two ways to answer that. The first is no, and the second is yes. So I would say no, it's definitely not magic in the sense that the rate-limiting step is still very hard thinking and a lot of creativity. And to speak to the title of the panel, although I do fancy math for a living, and I would love it to be the case that fancy math is really the rate-limiting step in terms of bringing data to innovation. I really do think it's much more like hard thinking and creativity, knowing your market and things like that. Fancy math will help. But I don't know that it's a rate-limiting step. With respect to magic, though, I think really what you need is a lot of domain expertise, and so I think in that sense the answer is no. The answer is yes in the sense of it's magic in the same way a magician is magic, which is to say it's not really magic, but if you are not well-versed in how somebody is doing something in machine learning or predictive analytics, it could look like magic, but it's not, and it's something that's readily more doable for everybody every year. At this point, you can download for free weapons-grade software for statistical analysis, the same coding base that Google is using, you can use for free. So it's getting less and less magic every year.
Allison, why does big data seem like magic to so many people?
Well, I think similar to what you said is, this is a little close, that there's no such thing as magic, but there's really sort of skilled sleight of hand. And I think working with data has a lot of similarities. And you can put a lot of data together, and you can definitely make a very convincing case of causality, but it certainly doesn't mean it's there. And a really skilled data person trained in data can take one look at it and tell you exactly what's wrong with it. But the average layperson or the average marketer, or doesn't necessarily know how to make that distinction, or even worse, wants to believe something that will definitely confirm their own priors. And it worries me when you start taking it to a commercial sense, when you don't really have that sort of same level of criticism. And we definitely are debating whether that's the advantage of peer review, which definitely is flawed in its own ways. But at least then you get a sort of a similarly trained critical eye on what's going on. And when it becomes more commercial, you don't have that. And it's very easy to believe things, make decisions on things when you unknowingly have bias or just sort of spurious results.
Matt, it looks like a lot of the startups that are employing data and data techniques these days, they have a bit of a magic pixie dust around them. Do you feel like there's a veneer of magic, at least, to some of the companies you're working with?
So hopefully from the end user standpoint, there is some level of magic involved from the perspective of the entrepreneurs and the VCs who love them. I think data science, or at least the implementation of data science in the context of a business, is incredibly hard work. I think it's probably going to be a recurring theme throughout this conversation, but I think we are at the stage where big data hype is meeting big data reality, and I think everybody got very excited. Everybody started all sorts of projects, and I think everybody, or at least a large number of people, are at a stage where they're now, okay, now what do we do, right? What technologies do we actually use? What people do we actually hire? What it is that we're actually trying to do? And there are ways through this, but I guess we'll talk about this later.
Gilad, are you a magician?
Of course. Do magic every day. I think with regards to magic, it seems like anything that has this sort of invisible power, at least seemingly to the users, like prediction, seems like magic. Like Nostradamus predicted when earthquakes would happen and when the world wars took place. And similarly, data scientists now are predicting when a tweet will go viral, right? Or when a YouTube video will supposedly become very visible. Or at least those are the claims, or that's sort of the story run by media. But I think what Matt was saying is very true, that when you actually come to implement some of these methods and do data work, especially at startups, people don't realize that the majority of the time you spend doing just incredibly hard, somewhat dirty work. You're getting data, you're cleaning it up, you're kind of working with it, trying to figure out what you can do. This is before you do anything fun or definitely anything predictive with it. So I think there's a lot of the output, or some of the output of our work can seem like magic, but when you're in the midst of it, it definitely does not feel like it.
So let's talk about the work a little bit, and particularly with regard to sort of the innovation or creative process. When you're working with entities like the New York Times or the companies that you service within BetaWorks, how do you find the sort of data function plays into product development, plays into creativity, plays into that generative function that we think of when we think of innovation?
So at BetaWorks it's effectively a startup studio, right? We have around 13 companies incubated at BetaWorks, some launched. There are new things that happen all the time. And the data team is effectively a shared resource. So it sits at BetaWorks, and we work across the different companies. And the idea is to first of all, build up knowledge and reuse solutions. So if we build a recommendation system for Dig content, we can use similar methods for Instapaper, for Bloglovin, et cetera. But the other part is using data streams or metadata that's coming in from certain products to either create a new product, a totally new product, or feed a really interesting feature in another product. So constantly sort of leveraging this central kind of data repository that's being built up over time to innovate and come up with new products. So I think I wouldn't say there's a set method that we use nowadays. There's either a very specific need, like a company comes to us and says, "Hey, we need to scale. Can we use some method or some fancy math to scale our product?" Or they say, "We need to score our content. We need to create a top trending feed or something. What should we do?" So that's when a very specific need comes to us, and then we figure out what's the right solution. Or we constantly sort of have to be experimenting and playing with our data to see what else can be done. And that's where some of the magic happens, where you're trying things out, you're doing some experimentation, and I mean, at BetaWorks at least, there's a culture of just kind of prototyping and demoing and releasing betas. So you put something out there and let people try it out. And based on the response, you can sort of figure out whether to take it forward or not.
Chris, maybe I'll take the question to you. You're relatively new in your role at the New York Times, but are there sort of patterns emerging in terms of how you interact with the more generative product development teams?
Yeah, I am new there, and also the company is very dynamic. I mean, it seems that way to me. Maybe it's just dynamic relative to academia, where sort of nothing ever happens. But the way that data relates to product or even editorial and marketing does seem to be changing rapidly there. And so I wouldn't say that it's formulaic, and I wouldn't say that it's static. There's definitely people there who are, it's not at all a data-phobic place. It's definitely data-philic, or at least data-curious throughout the company. And so, we get to work, to get back to Galad's point about how a lot of data science is really data engineering. There's a lot of hard work to take, big data in the form of weblogs or whatever you're handed and beat it down to the size where you can turn it into something suitable for predictive analytics. I happen to sit alongside a bunch of data engineers, so there's sort of a data science team that's part of a group that includes a lot of data engineers, which is useful for getting data that you can learn from. But in terms of how it relates to product or other functions, I think that's really a narrative right now. I urge all of you to go read the 96-page innovation report, which focuses on the role of the role of digital in the newsroom, which includes data, and that sort of spirit of self-critical, but eyes wide open and sort of optimistic inquiry about what is going to be the role of digital in newsroom is mirrored on the product side, the marketing side, and the technology side. So we're trying to focus on building models that are predictive, and predictive analytics might have impact. I mean, if you build a model that's predictive for user engagement or user behavior, because the features that are of interest may be features that are sort of action sets for the company or state variables about the user, those results may have suggestions or impact on product or marketing or potentially news. And so part of what you need is a company that's not siloed, so that people are willing to think creatively about how you can listen to your audience at scale and try to think about how to implement what the findings might be in very disparate parts of the organization. So I definitely would not say that, at least at the Times, there's sort of a formulaic idea about how data fits into the overall business function.
And Matt, I want to put the question to you a little bit differently. With startups that may be coming at it from, as sort of data natives, if you will, is there something different about the way that they develop product in a...
Yeah, I think that so I think it's a fantastic thing if you're a startup and you're lucky enough to have somebody like Gilad or Chris as your data scientist. And by the way, good luck finding somebody like that. I think that the harsh reality of for most startups, most of us, is that you're sort of at the beginning of it. You're trying to think, okay, I know I need to do something data-driven. I need to build a data-driven process into my product. What do I do? And actually, both in startups but also in large companies, I've seen again sort of big data hype leading to almost big data paralysis, where there's so many options and so many different things to do, but no real playbook on how to do it, that people sort of freak out and end up not really doing much. So what I've seen working is, one, take a deep breath. Two, at a minimum, make sure that you don't throw out any of your data. So that's the bit that every data scientist, and those people are infinitely more qualified than me to say that. But that's the one bit that is like the immediate actionable item across any kind of company, whether large or small. And then I think it's very much a baby steps approach, where instead of saying, hey, I'm going to build the most incredibly data-driven, innovative product in the world, let me try and do one project. And maybe the project is just not even a product, but just illustrating a point, and maybe that's just a white paper. And maybe the way you do it is not by trying to find a data scientist, but working with a data science consultant. There are a handful of them, just to get started. Or maybe even, and the data scientists here may disagree, but maybe you try one of those products, which is essentially data science in a box, which is never going to be as good as having a data science team in a house, but will get you started. So if you need commerce, a company like Costora, for example, which is essentially cloud-based predictive analytics, is a good start. There's a number of different products like that, Clear Story Data and a number of others. Probably not what you want long term as you scale, but maybe a good starting point.
Allison, you mentioned in the column that I talked about some of the challenges of doing just what Matt's talking about, trying to bring data into the organization. What do you see as the sort of lookouts that people should be concerned about?
Well, I think you just have to be very thoughtful. And I think we can learn a lot, actually, from the finance industry, which has been using enormous data sets for years. And I think definitely they've made some mistakes and have done some things better than others that we can all learn from.
One or two mistakes. Yeah.
Yes. Which we all felt. I mean, even with the financial crisis, why did they price these mortgage products the way they priced them? Because they used data that was like 10 years old and only had house prices going up. And that was really what was underlying a lot of their assumptions that drove their prices. And that's why these products turned up blowing up on them. And they had very large, sort of compelling-looking data sets, but you kind of have to take a step back and be humble and be like, well, what's this data showing? I'm only sort of concerned about prepayment risk, not maybe housing prices will fall, or maybe the last 10 years isn't a great indication of the next 10 years. And I was telling Justin as well, I have a lot of experience building a financial product that was very data-driven. And we spent a lot of time, we're having to make projections about what was going to happen to the stock market. It's a very hard thing. And we would debate furiously, and I was at a company that had a lot of very sort of famous economists, and I had these biweekly meetings where we would just, even they didn't know. I mean, there's 2 Nobel laureates in the room for empirical work, and they would just all debate furiously, how are we going to do this? And first thing we did was we took all the data we could, 80 years of equity prices to make a projection. And I think we said that, equities were going to return 8% nominally, which was too high. But that's what the data showed. And traditionally, in a lot of industries, and certainly finance in the past, would just take that, because that's what the numbers say, we're just going to do this. But then we took a step back, and we're like, well, is what's going to happen in the 20th century really going to happen in the 21st century? Maybe, maybe not. But are we really going to invest people's money? And under that assumption, that just seems irresponsible. So in the end, we tempered it with a lot of judgment.
We're kind of in this period right now where many of these tools are new. Certainly the scale of the tools are new. Scale of the information is new. That this is really a Wild West sort of period when it comes to applications of data in business. Do you have that sense?
I would say it's Wild West in the sense that it's very difficult to separate wheat from chaff. So the whole experience reminds me of what I and many other people went through in computational biology 12 years ago. So maybe around 12 or 15 years ago, biology became very data-driven very rapidly, and people started just doing whatever it took to get a publication, and the bar was not yet set for what you needed to do to manipulate your data until you got a publishable result. So, in fact, that was one of the things that really motivated me to learn more about learning, was reading papers that I couldn't really tell if it was wheat from chaff. So you see that a lot now in data science, I would say, that it's really unclear how to trust the veracity or integrity of what's being done to the data. And as we were saying before the panel today, that's one thing in an academic literature where the only people reading it are academics. It's qualitatively different now in data journalism where everyone is reading. I mean, if you're a journalist, right, the whole idea is you're writing for a publication that everyone is going to be reading. And so, although there's an interesting sort of form of peer review that's happening, even as recently as the last few months, with a set of different companies creating, a set of different publishers, creating different data journalism units that are critiquing each other's methods, it's still qualitatively different in that, there was an upper bar to how much damage I could do as an academic where I was publishing a paper in a journal, where maybe, 100 people would ever read that paper. And, at the New York Times, well, not the New York Times, but let's say any other publisher, you could do some damage there's a famous phrase from economics, actually, if you torture the data enough, it will confess to anything. There's
I
lots
didn't know we
of...
were the only ones who use that. I thought everyone
No,
did.
everyone uses it. It just
We
originates.
came up with it?
An economicist
We're
did.
always so pithy.
Dismal. But yeah, I mean, now it's qualitatively different in data science because people are doing some, often very sophisticated statistical analysis, and many people are exposed to and will use those results as forms of argument for influencing policy or, healthcare or decisions or economic decisions. So it's a bit more dangerous.
Yeah, I mean, sorry.
I would say on the business side too, there's so many startups that are now popping up in the space, like you're saying. It's very hard to evaluate what they're actually doing. I know some of them are, they file patents. It does feel a little bit like the Wild Wild West, like everyone's sort of filing these patents on these new, supposedly new methods that they're using, and so then they can't really disclose when you're actually digging in and asking, okay, well, what are you guys doing? Why should I use your product? So I find that, and some of what we do at BetaWorks is invest in early stage companies. So we evaluate a lot of these new startups, and it's not always easy to understand what's going on underneath.
Even at a publicly traded company. I mean, even at the New York
Yeah.
Times, right? I mean, the innovation report is in part making news because it's so rare to see such a transparent document about the role of data within a publicly traded company. But certainly for a privately held company, you have no idea. Matt does because he's an investor.
Mm-hmm.
But
That is your job, Matt.
Pretty sure someone leaked that report from
Yeah.
the New York Times. No, it has to have been leaked.
Sure. I don't think that was
But
ever
intentionally,
questioned.
no.
Oh, intentionally?
From the
Oh.
higher ranks, no?
That I would have to investigate the mind. You're asking me to speculate on the psychology of the witness. I'm not prepared to do that, Your Honor. But certainly it was written, in the second person. Right? The document was written as though it was written for Jill and Dean. Right? So I read the document as though it were intended for a very small audience with their own particular, context.
Yeah.
Yeah, I think it is a Wild West to some extent. I think it's all fine. It's just natural. I think we all need to think of big data as a 10-year secular cycle, at the end of which nobody will ever talk about big data again, which might be the good news.
Where are we in the 10-year cycle? Year
I
three?
think we
year
sort
four?
of year 2.
Okay.
1, 2, 3, something like that. But it's fundamentally big data central, the things that's enterprise technology, right? So it's not like Facebook or Twitter where you have 1 million users one day and 500 million the next day. All of this is happens very very quickly in the consumer world. In the enterprise world, there's this entire lag where one feels a need, then the market being somewhat efficient, you see a bunch of startups, a bunch of VC funding those startups. They come up with products. The products need to be implemented. The implementations go right or wrong. The next implementation typically is better, and so on and so forth. So it takes time. So it is at the stage where it's so confusing, but that's all part of the cycle. There is a trend though within the cycle, which is that the first 2 years, 3 years, whatever you call it, maybe 4 years. Was really focused on new startups emerging in pure infrastructure, so a lot of NoSQL type things, a lot of sort of core Hadoop. Then there was a wave that happened sort of at the same time, but a little bit after, which was around analytics. So gazillion companies from all sorts of different angles, from with visualization stuff that goes from hey, let's redo a big Excel spreadsheet to let's do some amazingly fancy visualization stuff. I think the trend now is moving towards big data applications. So you see both application in the sort of enterprise sense, meaning big data powered CRM, big data powered enterprise management software, but also big data applications, as in a bunch of new startups trying to reinvent industries using a fundamentally big data approach. So you see, big data in health, big data in agriculture, big data in education, and to me that's the part that's the most exciting because that will truly make a difference. So you can build technology for the sake of technology, but at the end of the day, it's about solving business problems and helping people, and the application part is what does it.
But it sounds like you're describing just the life cycle of any new technology, because
Absolutely.
Whether it's big data or a steam engine, it's like typically what happens is you have a new technology, and in the beginning, it takes a little while to catch on, and then people get very excited, and then ultimately it gets overused or used incorrectly, and then there's a backlash against the technology. But hopefully, and that's just the cycle of figuring it out. I mean, any technology is only as good as the technology itself, its use, and the correct application and the appropriate application. And probably what we're seeing right now with a lot of data use is just overuse or irresponsible use. But eventually, I think it's going to converge into sort of another really helpful tool or technology. We'll just have to learn, and there might be a 10-year period.
Yep. I definitely feel like data analysis is a bit like any other technology in that it takes a couple of decades for people to learn how to use it responsibly. Like you invent cars, and then a couple of decades later, you invent seatbelts. So, people, sort of do all these new things with data, and then they're going to make a lot of mistakes. And it'll take a while before people develop a good data sense and a good sense of smell for what people are doing with data.
I guess the hope is what you brought up, is that we just don't do any damage in the interim, like make bad policy decisions.
Or crash cars without seatbelts. We will. We have. Mm-hmm. We continue to do so. I do think the other way to augment Matt's cycle of technology is that in this case there were a few people. I think about it a bit like a gold rush. That like if somebody discovers gold, then a bunch of people are going to go after gold, and a bunch of other people are making a lot of money building pickaxes. So there's a lot of big data infrastructure companies that are now sort of profiting on the fact that there is a gold rush towards gold. One of the things, though, that's sort of missing from the history you pointed out is first somebody had to discover gold. So in the late 90s, there were a bunch of companies that clearly showed how to turn data and predictive modeling into a full-fledged company, right? Netflix, Amazon, Google. There's a couple of people that said, like, there's gold in these hills. And then there were a bunch of people running to find their own gold, to build pickaxes, to help other people who thought they were going to find gold. And then there were a bunch of derivative industries, like how are we going to turn gold into, filings for your teeth or rings or other sort of things where gold is part of the product but isn't sort of the central. It's not just that it's gold, but they're actually using it to create new products.
So I want to, before I begin to take your questions from the audience, so please do prepare them. And this has been discussed many times on every data science panel in the industry, this issue around talent and sort of engineering talent around data and the understanding of these methodologies, tools, et cetera, and the lack thereof, the sort of McKinsey numbers that are constantly flogged on panels like this about the lack of trained individuals to be able to take on data roles. From your perspective, is there anything new to say on that subject?
Sure. There's one thing I really wanted to say on the subject of talent, which is I'm hiring. Please. I just tweeted a job listing today.
I understand there at least 2/3 of these people are
We're
actually
hiring
already
in data science. We're hiring in data engineering. We're hiring.
On that topic, and this is kind of, I don't love the expression data scientist. Sorry, just because I feel like,
Good luck.
we all bring in our own biases as that. Like, I'm not a data scientist, but I work with data as an economist. So my interpretation of it and how I use it is going to be different than how you use it, or a sociologist, or they use small data sets, but you know what I mean? So I think, I feel like calling myself an economist who works with data kind of acknowledges my own biases, because you never just go theoretical into data.
Yeah, well, as somebody with a PhD in theoretical physics who applies mathematics to computational biology, you can imagine how strongly affiliated I am with any particular tribe. So it's not that I particularly venerate data science as a real thing, but it's a damn useful way to organize the skill set that I'm looking for.
Whatever we want to call them, how do we get more of them?
No, just quickly, this discussion to me is it sort of embodies the one of the key problems from a startup perspective in trying to recruit people is who are they? Who do we recruit? Are they statisticians? Are they people with a PhD in physics? Are they people that were in some analytics function and are trying to sort of graduate to become data scientists? This all these funny things happening, right? There's all those PhDs in sort of obscure topics that suddenly realize, hey, we can do something really cool, and they'll sort of, some of them at least, are coming to the industry. Then there's this furious race to rebrand. So there's a bunch of people that were doing something in analytics that suddenly, you see a LinkedIn profile changing to data scientist.
Anybody with a calculator was basically.
Yeah, exactly. So it's just extraordinarily hard to find it, and I think it's actually, to some extent, a little bit of an unsolvable problem because absolutely we need to train more people and create programs. And again, the market has been efficient. There's been a bunch of different programs. Like there's one which started in the Valley that's now starting here called Inside Data Science, where they take 40, 50 STEM PhDs and turn them into data scientists over summer. So it's interesting as an approach. But I think it's fundamentally, even if we train a bunch of people, I think my opinion is that there's a finite number of people that really have the chops to become a data scientist, because so those guys are incredibly rare birds, because as Chris was alluding to, it's not just being super strong technically. It's also being creative. It's being able to understand business problems. It's about being able to communicate with people around you. And there's just those are almost contradictory qualities you find in any single person. So it's hard to manufacture. And I don't think that the problem is going to get much better. Hence, again, not to come back to that, I think there is an opportunity around startups offering products that to some extent automate some aspects of the data science process, which again will never be as good as getting a data science team, but maybe good enough for a certain portion of the market.
Yeah, I would say that the skills part, there are definitely a growing number of university programs and online courses that are sort of getting at that, and we're seeing more and more potential candidates who come from those backgrounds. The one piece that's missing that we always look for is obviously experience or curiosity, or sort of having worked with data, or knowing how to ask interesting questions, or having that sort of that insight to figure out what to do with the data or the problem that you're trying to solve. And that, I feel like I don't know of programs that teach that, or I don't know of a program that can teach that in a year or two. It's sort of, as you work with data, as you're more experienced, you gain that skill. So we're always looking for people who've just done interesting things. So your background almost doesn't even matter, as long as you have some projects online, or some stuff on your blog or GitHub, or stuff that you've done, interesting ways that you've looked at data or analyzed it.
At Columbia, I should say, we're trying to create a discipline of data science. So I'm on the education committee for the Institute for Data Sciences and Engineering at Columbia. And that's one thing we've worked with for years, is try to figure out what would a curriculum in data science look like, in large part motivated by the fact that data science is now a job description. Whether or not you think it's a field of intellect, and whether or not you think it's an academic field, which it isn't, because I don't know of any departments of data science.
How can you answer the questions without an intellectual framework to begin with?
Okay, so as somebody who does a lot of clustering and statistical analysis, I really think that departments are, largely historical accidents from centuries ago. I mean, the thing that you do in computer science, for example, people in a computer science department could be writing proofs, they could be building robots, they could be making web pages. It's really sort of an it's an administrative utility to create a department of computer science, but it might be intellectually spread over, wildly different activities.
Which is what the Institute at Columbia is, right?
Is an attempt to be aggressively multidisciplinary and across different departments and across the entire university. By that, by saying whether or not you think it's an intellectual field, I don't mean that it doesn't have intellectual content. In fact, I urge you to go back and look at a 2001 document by a statistician called Bill Cleveland called Data Science, A New Field, where he lays out quite clearly what he sees as intellectually the core of data science. What I mean is, if you're going to build a program right now in 2014, and data science has been an active job description since at least 2008, that's simply realistic for you to look at the fact that you're trying to train students in a field that's defined by a bunch of job descriptions, and there is a cluster there around which you can organize a mixture of existing ideas from statistics, computer science, and brand new things that are driven by technologies that weren't around a decade ago.
One comment from Matt.
Yeah, just maybe quickly one related point. So there's a problem of hiring data scientists, which is huge, but there's another problem which I see more and more often, which is almost equally important, which is now that you've hired a data scientist or a team, how do you leverage them? How do you make them happy, productive, integrated? And there's a whole range of situations, but there are a fair number of cases where you end up finding the data science department being essentially siloed within the organization, very smart people in a back room somewhere. And obviously the key is to, precisely because those people are, if they're going to be good, are multidisciplinary and have all sorts of skills. The key is obviously to integrate them as much as possible with IT and businesses. But people have been sort of struggling because it used to be just IT and business, and God knows that those two constituencies didn't always get on very well. and now there's the third very important constituency, which is data science, and there's like this sort of reorganization on the fly of practices within companies, which again nobody's sort of super sure how to do.
So you can't just buy them some cloud subscriptions, stick them in a back room, and come back and check on them in 6 months.
You can try.
You need to water them.
But they may protest.
So questions from the audience. I know there must be some, given we've got such a informed group. I've got one right here.
For starting startups, right? And when the startup really highly depends on the data analysis, like, is there any? I don't know whether Chris mentioned in the beginning, but is there any free tools out there that maybe they can start using?
Generally, for an early stage startup, you have to get the data and then you have to make it usable for data science before you start doing data science. So I think really what you need is a bunch of good data engineers first, and also you need a good vision for how those people are going to contribute to enhancing shareholder value. So either you're going to build your product around data science, like it's going to be based around a recommendation engine because you're going to sell things at scale, or you're going to have a bunch of people who write a cool blog about things they had and found in the data, which is totally fine. That can be useful for drawing in advertisers or investors or acquirers. But you just need to set out, like, why are we hiring a data scientist, and have we done the appropriate data engineering so that the infrastructure is built that we can actually do some data science. You know, I'm fortunate that at the New York Times they've invested a lot in the last 2 years doing the data engineering so that, you know, it's not like raw web logs. I mean, there's a lot of processing to the point where interaction data are amenable to data engineering and then data science. So to my mind, you really need to make sure that you have some data engineering in place first before you even start hiring a data scientist.
Or
Yes, sir.
hire someone who can do both
Or hire a unicorn.
at that early stage. But
If you can't do it yourself, I guess. Yeah. Yes, sir.
Just one quick thing. Since Chris opened the door, my company was looking for a data science team.
How many people here are hiring?
Well, actually, I did have another question, which is, so I'm a product owner, product developer, and I'm wondering what degree of fluency do I need to really leverage the data science team? What's the shared language between product, business, other stakeholders, and the data science team?
So as a manager, what do you have to know?
I'd say you need to have some. You need to have experienced enough data science-driven products that you have some creativity about what it can do, but you need also enough to be literate enough to know what's impossible. Usually, I think the problem is getting people to think creatively about how data could be used to solve a problem. But you know, also it would be useful for everybody not to waste a lot of their time thinking that you're going to get blood out of a turnip, I think is the phrase. The other piece of my analogy earlier about gold rush is that not long after you get a gold rush, you get people selling fool's gold. So you need to have enough literacy that you can smell fool's gold.
Foster Provo at NYU on data science for business. He actually talks about that subject in depth, what managers need to know in order to manage.
Widely in our organization, but
Okay.
I was just wondering what else.
Here.
When you are either representing the company or the person in a company that's representing or driving the data, how do you get people that aren't used to working with data or trusting data for decisions to incorporate it?
So a variant of the last question, actually.
So the advice I gave at a meetup a few months ago is find out the thing that people who are the deciders care most about and build a model that predicts that. So, I mean, don't do a bunch of clustering on something nobody cares about. Try to find a project where there's something that people consider sacred or valuable or is clearly tied directly to shareholder value and build a predictive model of that. So then at least people will understand why it's useful.
And make it easily consumable. So make it visual. So that the people that you
Gilad's much better at that than I am. So.
actually make art, like Chris Wiggins would say.
No, not at all. Gilad
But
is good.
so the way, yes, attack a question that is valuable within the organization, but also make it easily consumable.
Pretty pictures are important.
The last big data panel I went to, they said that e-commerce had the least sophisticated application of data science, and I'm curious if you agree with that, and if you have any examples from by industry, like things that you're excited about with big data.
Where do you buy your books? Where do you buy your books?
Or anything.
Yeah,
I think Warby Parker is doing some interesting stuff. They have a data science team that's kicking ass. I'd say, yeah, sorry, go for it.
No, but I think it's true to some extent. And again, the market being somewhat efficient, there's a bunch of startups that are coming up trying to do those things. I think I mentioned Custora, which I'm not an investor. I have no particular ties.
What's the name of it? Sorry.
Custora, Custora, which is a New York-based company. It's trying to offer predictive analytics on demand. But there's for the Fortune 500 type companies, there's a bunch of companies coming up, from Lattice Engines to others which are building solutions. But the whole premise of big data for e-commerce is mass personalization and customization at scale, and it's not happening just yet, right? You should be showing up on a website, you should know who you are, or it should be, if the site doesn't know who you are, it should be able to predict who you might be based on any data that they can get, and they should be showing you the red sweater that you've been wanting to buy. So there's some of that happening in the advertising world, but there hasn't been much of that happening in e-commerce yet, and I think that's a great opportunity, and it's happening.
Also, Etsy. Right, so Etsy has a huge data science team. In fact, they have two. One data science team that's in R, and they sort of write reports, and another data science team in Python that's writing production data science. If you only have a couple of viewers or a couple of items, you don't necessarily need that type of data science. But if you have a lot of items, or if you have a lot of users and you want to treat those users differently, for example, if you want to build a rec engine for different stories, then you'll need some data science.
Another question? Okay, I'm gonna. I'll get one more over here. One more.
Just to go back to what you were saying a minute ago about pretty pictures and visualization. I'm a designer, and I've noticed this sort of emerging data visualization scene with plenty of gold and also business gold in there. And I was wondering what your opinions are about that scene, and how you would like to work with designers, because I think there's some opportunity for visualization as a learning tool, not only as publishing the end result or communicating the end result of data. I wonder if you could share any.
I think I've been encouraged by some of the sort of the advancement in data visualizations that we've seen over the past couple of years, especially in telling stories. So it's not hard to make a flashy network graph or data visualization that draws a lot of attention. In fact, I use those tactics sometimes when I want to get attention, but it's not. It definitely is not something I'd recommend for if you want people to actually dive in, understand.
It's all about capturing data and making use of data. Drones are fundamentally data capture platforms, and all the companies that are going to be successful in this space are companies that are doing it that way. It's going to be a world of personalized medicine, where to Chris's point, it took many years and a lot of disappointment, but the whole space around genetics seems to be hitting an inflection point where not quite announcing that cancer has been cured, but there's been tremendous progress being made recently, and all of this is fundamentally big data analysis.
I think we'll see a lot of magic when we know how to better deal with the intersection of human judgment and automated systems, especially with recommendation systems. So I'm looking forward to that.
Yeah, Matt took one of mine. So mine is health. So wearing my hat for a moment as a Columbia professor, I'm also hiring in a new NSF-funded project to apply machine learning methods to electronic health records. So Columbia also has a hospital, which means it has abundant health records. And we're very interested in how to build predictive models of people's disease progression, how to build models that might augment doctors by suggesting what tests should be done now. And health as a system is broken and ossified, and the right thing to do when somebody presents to you a system that's ossified is to start breaking bones and have them be reset. And that's happening both from policy changes like the Affordable Care Act, and as Matt knows, there's an abundance of data-related health startups happening on both coasts. There's a lot of people thinking about how to disrupt and disintermediate the entire health system and via data. So I think that's going to be really up for grabs and really exciting. I mean, it's not like a problem where it's sort of difficult for any person to understand what problem is being solved, like better data tools for BI, business and intelligence integrating with something else. It's like people getting sick and something that everybody can understand and is carefully watched, and there's just tremendous abundance of data that have been underexplored and underexploited.
So if I were to pluck some phrases from the conversation today to try to summarize, everybody take a deep breath. It's the Wild West of big data. There aren't any seatbelts yet, but we should go out and pursue the mind-blowing. Does that sound about right? And if you shake Chris Wiggins upside down, lots of jobs will fall out. So
I'm hiring.
you might want to see him after this. I want to thank our panelists. I want to thank Northside Festival, and I guess, given it's Williamsburg and it's Northside, it's time for you all to go have breakfast. So I hope you'll do that and enjoy your day. Thank you, guys.